This video will review over how to approach manometer problems. Now, a manometer is an old simple way of measuring pressure. It's typically a U-shaped tube that's partially filled with a liquid, either water or mercury, and it is connected to a pressure source at each end. The difference in the liquid height corresponds to the different pressures, and this difference in the heights of the two arms can be used to find the gas pressure. Now here we can see the U-shaped arm of the manometer, and what we're looking at is the difference in height between the two sides of the arm. Now here we have the gas side and here we have the atmospheric side, and depending on which side is higher will determine how we approach the problem. Typically speaking, the manometers used for measuring gas will either be opened or closed. Now here we have our gas connection. This would be atmospheric. Notice right here that this is closed while this one is opened. We approach closed manometer problems different from open manometer problems. Here we will be looking at closed manometer problems first. Now the conversion that we will use is 1 kilopascal equals 7.5 millimeters. The problem we will be solving is right here. A closed manometer is filled with mercury and connected to a container of argon. The difference in the height of the mercury in the two arms is 77 millimeters. What is the pressure in kilopascals of argon? We can use this conversion right here, and we will convert the 77 millimeters of mercury to kilopascals. We have 77 millimeters of mercury times 1 kilopascal over 7.5 millimeters of mercury. Millimeters of mercury cancel out, and so we would have 10.2 kilopascals as our pressure of argon. Now, open manometer problems exist in several ways. We can have the problem where we have a height difference where we have higher in the gas arm versus the atmospheric arm, or we can have it where our atmospheric arm is higher than our gas arm. And so we look at these two problems and the solution of these in different ways. When the height is greater on the side connected to the gas, then the air pressure is higher than the gas pressure and it's pressing down on the fluid. Now when we have these, you subtract the pressure that results from the change in the height of the mercury container. So the first thing we would do is to convert our millimeters of mercury, and then we would convert that to kilopascals, and we would do a subtraction. So let's look at an example problem of this. Here we have an open manometer that is filled with mercury and connected to a container of nitrogen. The level of mercury is 36 millimeters higher in the arm attached to nitrogen. The air pressure is 101.3 kilopascals. What is the pressure in kilopascals of the nitrogen? The first thing we're going to do is we're going to take our 36 millimeters and we're going to convert that to kilopascals. So 36 millimeters times 1 kilopascal over 7.5 millimeters gives us 4.8 kilopascals. Now I do like to sketch out our drawing just to see what's going on in our problem. So when we sketch this out, our problem says that we have a higher index going on in the gas arm than we have in the atmospheric arm. Here we have the gas and here we have the atmospheric. Now that makes a difference because when we have a higher area here in our gas arm, what we're going to do is we're going to subtract. So we take our 101.3 kilopascals and we subtract our 4.8 millimeters. That gives us an answer of 96.5 kilopascals. We can also have our manometers set up so that we have the atmospheric arm higher than on the gas arm. So here we have air pressure is exerting more force on the fluid, so the fluid compensates for this. And when we have this going on, we must add. So in order to do this, we're going to first convert to from millimeters of mercury to kilopascals, and then we will add that difference to whatever our atmospheric pressure is. So let's look at one of these problems. Here we have an open manometer that is filled with mercury and connected to a container of nitrogen. The level of the mercury is 24 millimeters higher in the arm attached to the atmospheric side. Air pressure is 100.5 kilopascals. I do always like to draw these problems out so I can visualize what's going on. So let's sketch this out. And when we sketch this out, we see that it's higher on the atmospheric side. And here we have the gas side. Now when we have it higher on the atmospheric side, we will be adding. If we have it higher on the gas side, we subtract. And that's why I sketch these out, is to see, do I add or do I subtract. So on this problem, we will take our 24 millimeters, we're going to convert that to kilopascals. 24 times 1 kilopascal over 7.5, we get 3.2 kilopascals. Notice that we have 100.5 kilopascals as our air pressure. We take that, we add the 3.2, we get 103.7 kilopascals as our answer.